All right, welcome. Today we're going to put on our detective hats and crack a case that, let's be honest, affects just about everyone working with data. I'm talking about the case of the corrupted dataset. We're going to hunt down the usual suspects that just love to mess with our data and figure out exactly how to deal with them. So, let's get our investigation started.
And this quote just hits the nail on the head. This is why our case today is so incredibly important. I mean, can you imagine building a fancy AI model or a critical business report on data that's just full of holes and errors? The whole thing is doomed from the get-go. Clean, reliable data isn't just a nice to have, it is the absolute bedrock of anything you want to build. So here's our game plan for today. We'll start by taking a look at the crime scene, the messy reality of real-world data. Then we're going to profile our three main suspects, the phantom of missing values, the imposter of outliers, and the echo of duplicates. And finally, we'll see just how powerful it is once you've cracked the case. Let's just get one thing straight right off the bat. No real-world dataset ever shows up perfectly clean. It just doesn't happen. Data comes from everywhere, from people, from sensors, from all sorts of systems, and somewhere along the way, it always gets messy. Our job as data detectives isn't to hope for perfection, but to know exactly how to clean up the scene. Okay, our first suspect is a really sneaky one. I like to call it the phantom of missing values. This culprit is a master at leaving behind empty spaces where crucial info should be, and that creates these huge gaps in our evidence that threaten to derail the whole investigation. So what exactly is this phantom? Well, it's just a blank spot, a null entry, a piece of the puzzle that's just gone. If you've ever used tools like Python with pandas, you know exactly what I'm talking about. You'll see these things pop up as NaN, which stands for not a number, or none, or sometimes just an empty string. They all mean the same thing. Our information is missing. Okay, so for any good detective, the first questions are always motive and opportunity. So how and why does our data vanish in the first place? What are this phantom's favorite tricks? And here are the usual causes. A lot of the time, it's just simple human error. Someone forgets to fill out a field on a form. Or it could be a system glitch, like a sensor that just stops recording the temperature. Or, and this one's interesting, it could be totally intentional, like when a user decides to skip a sensitive question about their income. Each of these gives us a clue about how to handle that missing piece. Now, we get to the fun part, the detective's toolkit. We've basically got two main strategies here. First, there's deletion, which is kind of like removing a contaminated piece of evidence entirely. Then there's imputation, where we use other clues in the dataset to make an educated guess and fill in the blank ourselves. So it's a big choice. Do we remove it or replace it? Choosing the right tool for the job is absolutely crucial. You can think of this table as your detective's cheat sheet. So if you're missing less than 5% of your data, you can see here just deleting it is often a safe bet. But for skewed numerical data, like income, where a few super high earners can totally throw off the average, the median, that's the middle value, is a much better choice. For categorical stuff like city, you'd use the mode, the one that shows up the most often. And for the really complex cases, you might use advanced techniques like KNN, which is pretty clever. It looks at similar data points to make its guess. Let's move on to our next suspect, a real master of disguise I call the imposter of outliers. Now, this is a data point that looks like it belongs, but its value is so extreme, so different from everything else, that it can throw off our entire analysis and point us in a completely wrong direction. Simply put, an outlier is just an observation that's an abnormal distance from the other values. This salary example is perfect. You've got 1,000 employees making between 40 and 90 grand, and then you have one CEO making $1 million. That $1 million salary? That's a classic outlier. It just doesn't fit the pattern. Now, these imposters can actually be genuine rare events, like that CEO's salary, which is really valuable information. But they can also be simple mistakes, like a typo where someone accidentally typed $5,000 instead of 500.00. Or, in some serious cases, they can even be signs of fraud. Figuring out if it's an error or a genuine insight, that's the real detective work. One of the best ways to unmask these imposters is the interquartile range, or IQR method. So imagine you line up all your data from smallest to largest. The IQR, as you can see in step 2, is just the middle 50% of your data. Then, as step 3 shows, we create a kind of statistical fence around this range.
Any data point that falls outside of that fence gets flagged as a potential outlier. It gives us a really clear mathematical way to spot these anomalies.
Another great little rule of thumb is something called the z-score. Basically, a z-score tells us how far away from the average a data point is. And the rule is super simple. If the z-score is greater than 3 or less than -3, it's basically waving a giant red flag. It's a really easy way to spot extreme values.
And this brings us to what might be the most crucial clue in our entire investigation. An outlier isn't automatically bad data. In fact, sometimes it's the most important data point you have. A fraudulent transaction is an outlier, and if you removed it, that would be a disaster. Context is everything. You have to investigate, not just delete. All right, on to our final suspect, the echo of duplicates. This culprit loves to create copies of records, and that artificially inflates our numbers, skews all our statistics, and makes us waste time and resources by acting on the same information over and over again.
So, a duplicate is pretty much what it sounds like, a record that shows up more than once. The easy ones to find are the exact duplicates, where every single column is identical. But the really tricky ones are what we call partial or fuzzy duplicates. This is where the same person or thing is recorded with small variations, like a misspelled name or a slightly different address.
And trust me, these echoes get created all the time in the real world. A user might accidentally click the submit button twice on a form. A system might log the same event over and over during an error. Or, and this one is super common, when you merge data from your website, your mobile app, and social media, you suddenly have 3 records for the exact same customer.
And just like with our other suspects, we've got specific tools for these duplicates. For an exact copy, you just remove it. Easy. For a partial duplicate, you'll probably need to merge the information into one complete record. For those case-sensitive issues, like Ravi versus Ravi, the first step is always to standardize your text, like converting everything to lowercase. And for the really tough cases, we can use what are called fuzzy matching algorithms to find records that are similar but not identical.
And this right here shows you why this matters so much. In e-commerce, if you have duplicate records for one customer, you might send them the same marketing ad twice, which is just annoying. But even worse, you'll completely miscalculate their lifetime value, and your recommendation engine will be working with bad data, which means it will give bad suggestions. So there we have it. We've identified our 3 main suspects, and we've learned the techniques to track them down. By closing the case on dirty data, we finally unlock the true potential that's been hiding in our information all along. All that detective work really does pay off. And here is the reward for all our hard work, visualized perfectly. When you clean your data, the accuracy of your machine learning models just shoots up. The reliability of your business insights becomes something you can actually count on. And as that third bar shows, the amount of time and money you waste on bad data just plummets. It's a win-win-win. So let's bring this all together with a quick, practical example. Let's say we have this customer data set right in front of us. Each column needs a different plan of attack. For age, with only 4% missing, median imputation is a great choice. But for last purchase date, with 20% of the data missing, we have to ask a serious question. Is this column even critical for our analysis? If not, the smartest move might be to just drop the column entirely. We've unmasked the phantoms, the imposters, and the echoes that corrupt our datasets. By using these detective techniques, you're not just cleaning data, you're unlocking its true story. The power is now in your hands. So the question I'll leave you with is this: what incredible hidden stories will your data finally be able to tell you?